All right, so now let's try another example. So this is looking at a squared function. So we're going to consider sine squared theta minus 3 sine theta plus 2 equals 0. And we're going to do this again both ways because it'll be asked both ways in your homework. So you'll be asked to either solve on the interval from 0 to 2 pi or to find all solutions. So we'll do both. All right, so when you have a squared function in the equation, often you can factor one side of the equation. So if you have a squared function and it's not set equal to 0, the first thing I would do is set it equal to 0 and then see if it'll factor. So if I take sine squared theta minus 3 sine theta plus 2 equals 0. So this is going to factor like a quadratic. So basically we're reversing FOIL. So I know that sine theta times sine theta will give me sine squared theta, and I basically can use factors of 2 for my other slots. And then I know when I add inside and outside, I have to have negative 3 sine theta. So my choices are really just negative 1 and negative 2. So if I take the time to multiply this back out, I will end up with what I started with. And now, just like in algebra, I'll set each factor equal to 0. And then solve them. So I have sine theta is equal to 1 and sine theta is equal to 2. Okay, so two things should stick out to you here. For one, with this one, right? If you think about sine theta, especially if you think about the graph. So, right, theta would be your input, this would be your output. So when you think about it, right, your sine function looks like this, and it'll keep going on forever and ever. It oscillates in between 1 and negative 1. It never goes up to 2. Sine theta doesn't. I would have to have a different amplitude, right? So there is no solution to this. Sine theta equals 2. Sine theta never equals 2. The 1, this is where you want to think about, again, when you get sine values of 1, that's when I'm thinking about the unit circle. And that's where my cheat sheet comes in handy, right? So remember, sine is the y. So as I'm looking at these 4 points, when is the y coordinate 1? That's up here at pi over 2. So when is sine theta equal to 1 on the interval from 0 to 2 pi within 1 revolution? Is theta is equal to pi over 2. Sine of pi over 2 is equal to 1. So that's the only solution on the given interval. Now if I want to find all solutions, I would just either add 2 pi or subtract 2 pi infinitely. So all solutions would be pi over 2 plus 2k pi, where k is an integer.